This module looks at a statistical tool called the standard deviation, the fundamental and most important measure of variability in the set of data. Let me begin by asking you a question. Is everybody exactly alike? Dr. Rasp, that is a really stupid question. Of course not. Okay, so how do we measure the amount of variability in a set of data? That's a much smarter question. That's the focus of this module. The standard deviation is the most common and useful measure of variability. And it is the average of the squared distances between the data points and the mean. In other words, the standard deviation is the amount of deviation that is standard. It's amazing how we come up with this term. Seriously, if you simply think about what the words mean, it typically tells you how to find them. We are looking at the amount of deviation, of difference, of variation that is standard, that is typical, that is ordinary. So let's work through a simple example. I've got data on 5 individuals, a random sample of 5 Stetson students, and these are data on the number of hours of sleep they got last night. 6, 0, 8, 2, and 4 hours of sleep. We would like to find the sample standard deviation for these data. Remember that standard deviation is average distance from the middle, and so let's look at the middle of the data. The data were 6, 0, 8, 2, and 4. The average person in our sample got 4 hours of sleep. We then look at distances from the middle. The first person in our study, Alfonso, got 6 hours of sleep. That's 2 hours above average. Second person in our study, Balf, pulled an all-nighter. Shame on him. That's 4 hours less than average. Third person in the study, Clorinda, got 4 hours more than average. Fourth person got 2 hours less than average. That was Dietrich. And Elwood, the fifth person in our study, got right at average amount of sleep. Distances from the middle. Notice, by the way, the negative numbers here balance out the positive numbers here. That will always happen. And so to keep the negative numbers from canceling the positive numbers, we're going to square everything in sight simply to make the results positive. So 2 squared is 4. Negative 4 squared is positive 16. 4 squared is 16. Negative 2 squared is 4. 0 squared is 0. 4, 16, 16, 4, and 0 are our squared distances. I simply repeated those numbers here, 4, 16, 16, 4, and 0. These are the squared distances from the middle. We want to, in some sense, average these. Now we're going to take a slightly creative average. Normally we would simply average 5 numbers by adding them up and dividing by 5. But these represent a sample from a larger population, a larger group of people. And that larger group of people quite probably has more variability than is captured in our sample. We were looking at number of hours of sleep, and our data run from 0 to 8 hours, but there are probably people on campus who got more than 8 hours of sleep last night. At least one hopes so. And so when we find our average, so to speak, we're going to add them up, but we're going to divide by a slightly smaller number. not the sample size of 5, but the sample size minus 1. Add them up, divide by 4, the result is 10. And that number is something called the variance of the sample. To get the standard deviation, remember we squared everything in sight. We'll take a square root again at the end of the process to put things back in the original units. Our standard deviation is the square root of our variance, square root of 10, or 3.16. So let's work a second example here. The numbers now are 3, 7, 6, and 8. I'm going to ask you to take a couple of minutes and work through, compute the sample standard deviation for these data. I'm going to ask you to pause the video, work through this problem. You don't learn by watching me work problems nearly as much as you learn by working them on your own. So pause the video here, work through the sample standard deviation of these data, and when you've got a number, then restart the video to check your answers. So here's our solution. Average distance to the middle, so the first thing we need to know is the middle of those data. Those numbers, add them up, divide by 4, average is 6. We look at distance from the middle, 3 minus the middle, we're 3 below average. 7 minus the middle, 1 above, right at average, 2 above average. Notice the negatives will balance out the positives. To keep that from happening, we square everything in sight. Minus 3 squared is positive 9. 1 squared, 0 squared, 2 squared. Take those squared distances from the middle and average them, in air quotes. Add them up, but we divide not by 4, but by our sample size minus 1. 4 data points minus 1 is 3. That gives us a sample variance of 4 2/3. The standard deviation is then the square root of that quantity, 2.16. If you've got the computation nailed, you can stop here. If you want an additional practice problem, keep going in the video. We'll work through one more example. So here's the second practice problem. Here are our 6 data points. Your mission is to find the sample variance and standard deviation. Once again, pause the video here, work through it, find a solution, then restart the video to check your answer. Average distance to the middle. The middle, add them up, divide by 6, the average is 3. Look at how far each data point is to the middle. 3 minus 3 is 0. 1 minus 3 is negative 2. 4 minus 3 is 1, and so on. These are our distances from the middle. We square those to keep the negatives from canceling the positives, and take an air quotes average by adding them up and then dividing not by our sample size of 6, but by 6 minus 1, which is 5. That gave us a sample variance of 2.8, so the sample standard deviation is square root of that, 1.67. In terms of general expectation, you should be able to compute the sample standard deviation by hand for a small set of nice numbers. That shows conceptual understanding of the statistic. You should also know how to use software tools to get the data for larger real-world data sets, The next video in this module looks at how to do that.